Hello, my name is Peng. My role in this project was to perform the Unity UI and scripting integration. In other words, I'm responsible for some of the programming, and that also means that I'm also responsible for tying the scene and the script together. And I also did the technical documentation for this project. Now, for the design goal of this project, we need to have the components of the project in multiple separate forms. So that means like in separate scripts and in separate Unity components. This make it easier to reuse certain codes and prefabs if you're looking for specific functionality. This also means that updates in one script will also benefit all the other components that are referenced in. For the project itself, if you simulate kinetic art, which is an art form which have a design a platform which basically animates with its various components. So for the platform simulation, which you have a board layout with a preset of platform patterns, and if you simulate the movement of these platforms across the board, that means that you should have control for the platform board dimension settings, which have the adjustments for the width and length, which are all based on the default individual platform sizes. So the units of the board, the unit measurements of the board are based on discrete units. Uh, you should also be able to adjust the height displacement of the individual platforms. So each platform could have their own unique displacement. So when they all combine together, it creates a three-dimensional pattern. And so and the preset platform should also be able to be saved. So that means that you should be able to load this save pattern from file and to be able to simulate the pattern at any time. Now for the design goal system behavior, the project should start from the main menu, which allows the user to navigate to the configuration, programming, and simulation screen to perform specific actions, which leads into the configuration screen, which allows the user to specify the design and specification of the platform boards, which also allow you to be use the programming screen to allow the user to program the set pattern of platforms, which is then could be used in the simulation screen, which allow you to simulate the movement of the patterns of platforms across the screen, which will be played out with certain animations. This is our logical high-level design. The various components pretty much all interact with each other in various ways. And now you will notice rather quickly that the UI manager have most of the connections with the other components. Uh, this is because it is the primary script for communicating the status of many components to Unity to Unity to be aware of. So in other words, it also allow responsible for keeping Unity up to date with what's happening in the script files. Now, the main purpose of this diagram is to help us understand why we need to send receive data to certain classes and scenes. So it also, in a way, help us in the debugging process.
Hello, this is Abdulla Binissa from Team G. This is our platform simulation final presentation. Here I will discuss how we achieved the simulation. Basically, um, we created an array in our platform manager. Since our platform manager is an instance, so it's only one of that object. So we created a 2D array, kind of a global variable that will not be changed throughout the simulation while the simulation is running. And this 2D array, it will contain the height at which each node is at. Then while the simulation is running, each node will find what the next position it needs to be at for the next iteration. And for each iteration is when So the iterations start when each of the nodes are in the next position. So that way the simulation can be incremented, and then all the nodes can set their next position. I'll show you more in this. So here's on the right is the platform manager script. In the specific function build platform from file, on the bottom you'll see a platform program at node data I, node data j equals node data. Basically, this is our 2D. This is our 2D array that we use to store the height in Platform Manager. So yeah, on their left will be the platform data node so this is in each node. This is the function simulate. So each not frame, but every iteration, every time it needs to have a new position picked, it'll run this code. So basically, when it's ran, simulate would be false, so it is set to true. And then it goes down, and here's a variable I named flup on out of haste. I forgot to rename it later, but basically this is the value that it is choosing in the next array. So let me explain a little more. So row is another variable that is within platform data node. Now each of the nodes have this variable, but it's all the same for each node. It's initially at 1, but every time row is decremented, it's decremented for all the nodes. So no matter which node you're in either time, it's going to be the same value for every node. Basically, so this would be the platform program data, the 2D array that's like immutable. Excuse me. So the way we pick the next position, flup, we get the row plus I. I is the row that the data node is in already. So let's say we're trying to animate this node in particular, 1 and 1, I equals 1, j equals 1. So I would be the rows, j are the columns. So all we care about is the ith are the rows. So the animation can move from up to down. So how we get flup is that we have to get the row in which is being animated per se. So row would be 1. I would be whichever node you are at. So that would be like 1 and 1. So you'd be in row 2 minus PCDM, which is the full length of the 2D array. This causes the animation to move from here to the next row, to the next row, to the next row for each individual node. And you're accessing the platform, the 2D array named platform program right over here. Next position equals this. Now the 2D array is actually made out of nodes. It didn't really need to be. It could have just been made out of like a 2D float array, but it's a 2D node array, and then we have a next position function call right here that will give us the position that it is at, or the height that it has. Then after the next position is found for all nodes, we decrement row, but we don't allow it to go past or below 0. So it would just loop. So yeah, that's how we simulated it. Hopefully that made sense.
Hello, my name is Khitab and I'm going to continue this presentation. My other group members already gave the basic idea of our project and the main problem, which is simulating the platform. So now I'm going to talk about the user interaction. My role in this project was the UI polish and technical document. So we can navigate through different scenes using the buttons. The first scene is the main menu. There is the setup button, simulate button, the exit button, and the program button. In the first scene, the setup scene, we can change rows and columns of the platform using input field, and there are two sliders for spacing between the tiles and between the nodes and the range of the y-axis. So we can change that tool, and then we can click on the build platform, and we can see the platform will be created in the background. In the top panel, we can see that we can navigate through other scenes also. We can move directly through to the program scene and main menu from using that button, and the values of the m and n will be shown on the top panel. In the program scene, we can select specific nodes and we can change its height, but we have already specified the range of the y-axis. So if we have specified it to be 1, then we cannot change the height of the node above 1. All right. When we have when in the platform program scene, when we have selected all the nodes and we have changed its height, then when we click on the program button, it will store the data in the text file. That means all the data of the selected node and its height will be stored in the text file, and it will be used in the simulate scene. Also we can use arrow keys and left shift to zoom in and zoom out. Sorry, there was some disturbance in the background, so my voice wasn't audible, so I had to re-record these portions. As I was saying, you can change the position of camera using the arrow keys. We can use a combination of left shift and arrow keys to zoom in and zoom out. So in the setup scene, we can change the number of rows and columns for our platform, and the spacing between the nodes, and the range of our y-axis which will be shown on the top panel. And in the program scene, we can select individual nodes and adjust its height, which will be so when we click on the program button, it will be stored in the text file, which will be used for the simulation of the program. My role was polishing the UI. So let me show you what I had done in that area. So I had used some animation for panel and the button. So as you can see, I have used the scale and the color animation. So whenever the cursor is over this button, the size of the button is increased and the color of the button is changed. So the way to do is do is that we have to use the animator component. So uh, and when we have added the animator component, then we can use the automatic animation generation. So it will give us four states, which will be disabled, pressed, highlighted and normal. So in the highlighted state we can apply this animation, and for the panel uh, I have I have used anchor maximum property. So using this property, we can make the panel appear from the left, and also I have used the alpha property. So at the start of the animation, the alpha will be 0, and at the end it will be 1. And when we are using this animation, we have to make sure that the loop time is turned off, otherwise it will be animating back and forth, do not which we do not want. The main challenges I faced was the details, because as number of UI elements increases, uh, and we have to really give attention to details, because it's really sometimes it's really frustrating. So yeah, the attention to detail was the main challenge I faced during the polishing the UI. So now my group members will give you the demo of our final project. Thank you.
Hello, so this is our demo. This is the main menu scene, basically the navigation for the whole program. Here we go to the setup screen. We'll have our choice of the M and N value, which I guess we'll just have it 16 and 9. And we also have the delta spacing for individual, for the spacing between nodes and the y-axis range. Let's just max that out, and then we could build platform. And you see here we have the platform 16 by 9, and using the arrow keys we can adjust the camera, and we could zoom in and zoom out. We could also change the delta spacing a little more if you like, and maybe make it a tiny bit smaller. Maybe let's have it 9 by 6. Oops. Actually, let's just keep it at 16 by 9. And now, if we move forward to the programming scene on our top right hand corner, we'll be here. And here we can program individual nodes. So let's select this node, give it a height of maybe 0.8. This node be 0.8 as well. And maybe we could have like some sort of arrow. And it goes like that, maybe. And now we program platform that saves the data into our file. And then here we could go back to setup, or we could go to simulate, which we'll do. And it will simulate. Whoa. Well, it's going the other way that I expected, but yeah. So each node is going to the next position that it should. And then when it reaches the end, it just starts from the beginning and it loops around. Back here we could go back to the setup, maybe change the dimensions 3 by 3, build platform, program platform and simulate, and then we have another simulation. Or maybe we could just go to program and program something different, and then simulate that, and we have the same setup but a different program. We could also exit, but I think that'll end the recording. Let's try exiting. So if we exit and we reopen it, no, it's not reopening. Oh, there we go. So this is a new, I just closed it and I reopened it. And now if we go straight to simulate, it's going to be there still. So that means that we successfully read from the file and we saved it. And it's no longer in the program, if that makes sense. So yeah, that is our demonstration. Thank you.
Now for the design approach was the challenge and the lesson learned. One issue was communication. Since it was difficult to find the available schedule for each of the team members, so we had to use email to chat and discuss issues and solutions. So we also try to discuss them in class. But overall, this means there was some serious lag in communication. Another challenge was the version control, since it was difficult to make sure we're all working on the same project. So we use Google Drive as a project asset library and communicate the updates and bugs through the email. And for the lesson learned, we learned how to use the C# in multiple scripts that communicate with each other through the use of events and delegates. So that was a part of the learning process of having multiple scripting files and multiple scenes. So each could be adjusted separately, and also to have each individual events control certain actions. And we also learned the logical and time-dependent thought process. That means that the programming the events to happen in response to other events occurring and in response to user events. That means it's easier to make sure that certain events only happen at certain instance. So it's easier to control what happens in the program. And finally, we learned exactly how to go through the proper debugging process, which have a side effect of also allowing us to learn exactly how the program works, especially if there are any unintentional design behavior. And then that's all. Thank you for your time. We hope to see our next stage of the project.